Hello and welcome back to Math Class with Mr. Kura. Today we're going to be starting our second lesson in Unit 1, and we're going to be talking about cube roots. So first of all, we should understand what the symbol or notation looks like for a cube root. So it looks just like our square roots from yesterday's lesson, except for we put a little 3 up there for a cube. Now, what does a cube root mean? How do we find a cube root? When we're looking for a cube root, we ask ourselves what number multiplied to itself and itself again is the number inside the cube root. So for example, the cube root of 8, and we would say this, it's important we know how to say this, the cube root of 8 is equal to 2. And we know this because 2 times 2 times 2 equals 8, right? And if you not sure on that, let's think about this. 2 times 2 is 4. 4 times 2 is 8. So the cube root of 8 is 2. Now what about the cube root of 1,000? Think about it for a minute. What number multiplied together with itself 3 times? So something times that number, and again 3 times is equal to 1,000. 10 is the cube root of 1,000 because 10 times 10 times 10 equals 1,000. We'll kind of do the same thing as last time. 10 times 10 is 100. 100 times 10, 1,000. All right, now let's go through our list of perfect cube roots. It would be very handy and helpful to have these cube roots memorized maybe after today, after a couple days, but these will come into play. So we already did the cube root of 8 is 2. The cube root of 27 is 3. Because remember, 3 times 3 is 9, times 3 a third time, 27. Cube root of 64 is 4. Cube root of 125, 5. Cube root of 216 is 6. And the cube root of 1000 is 10. Alright, now we'll move down here and we're going to be estimating cube roots to the nearest whole number when they are not perfect roots. So this goes just like our square root process. If you didn't watch that video, it might be helpful to watch it before you do this one, but not necessary. You don't have to, but it might be helpful. All right, so the cube root of 14 falls somewhere. Let's have this so we can see. Falls between 8 and 27, right? So it falls between the cube root of 8 and the cube root of 27. But is 14 closer to 8 or 27? It's only 6 away from 8. It's a lot more than 6 away there. So closest to the cube root of 8. So we would say roughly or closest to 2. And it's a little bit bigger than 2. Sometimes I like to make myself a little bit of a note next to it and say, okay, I put a little plus sign up here just to remind myself this is bigger than 2. Since 14, these should all be cube root. The cube root of 14 is bigger than the cube root of 8. Cube root of 8 is 2, therefore this must be bigger than 2. All right, cube root of 65. Let's look at that. So 65 falls between the cube root of 64 and the cube root of 125. And it's closest to, this one should be obvious, it's just one more than 64. Closest to the cube root of 64, which is roughly 4. And then is that bigger or smaller? 65 is bigger, so bigger. Cube root of 23. let's see, that falls between 8 and 27 again. Cube root of 8, cube root of 27, and it's closest to cube root of 27, which is 3. But this one, 23, is less than 27, so this is a little bit smaller. That tells me it's like 2.9 or something like that, a little bit less. All right, and a quick little note down here. Non-perfect cube roots are numbers that go on forever without repeating. Does anyone remember what those kind of numbers are called? Think about it. Those are called irrational numbers when they are numbers that go on forever without repeating. All right, thanks for spending more time in class with me, Mr. Kerr, today, and I look forward to talking to you again soon.